So student investigate the cooling of water. This one is October 19 paper. So what is the temperature of the room? That is 24 degrees centigrade. Then student pour 200 cm cube of hot water into a beaker. He then place a thermometer. He measure a temperature theta of a hot water in a beaker. He immediately start the stopwatch and he's measuring for every 60-second interval. So you can use screen annotation to complete this, the column for time. That's right. And then complete the column heading. Column heading means the units which are used here. So that's good. Then calculate a decrease in temperature for first 120 seconds. Like how much temperature decrease for first 120 and for last 120. Like if I complete here, this was 60, 120, 180 and 240. So for first 120 second, what is the temperature decrease? That is 10. And for last 120 second, from 120 to 240, what is the temperature decrease? What is the decrease in temperature for last 120 seconds? From 120 to 240. From 120, you have to include 85 here. It's not about from, because this is 180, so it is from 120 to 240, means from 85 to 78. This was 10, then 85 to 78 is 7 degrees. Because it is 85 minus 78, which will make 7. You have to tick a box. To tick the box to show a conclusion from a result. Look, first 120 second, the temperature changes by 10. Next 120 second, temperature change by 7. So which is a right statement? Which box we should tick? Average rate of a cooling is less in first 120 second than the last 120. If you read this, the values here, if you check the values, if you check these values, you will find for first 120 seconds, it cooled down by 10 degree, like it changes the temperature by 10 degree. But in the last 120 seconds, it cooled down or decreased the temperature by only 7 degree. So which one was faster cooling? Which one was a greater rate? So initially it was faster and the later it is slower. So which box we should take? The average rate of a cooling is greater in the first 120 seconds than in the last 120 seconds. Then justify your conclusion by reference to the result. So what we'll mention? So we'll mention from 0 to 120 seconds, the temperature changed by 10, but from 120 to 240 seconds, the temperature changes only 7 degrees. Suggest two ways in which the student could reduce the rate of heat loss from the beaker in this type of experiment, like how we can reduce the rate of the heat loss. So we should provide an insulation, or we should place a lid, or the room temperature, the starting temperature should be low, because if starting temperature is low, rate of heat loss is smaller. If starting temperature is high, rate of heat loss is low. Or we can reduce the surface area. So how we can reduce surface area of the container, or we can use a lid to reduce this rate of heat loss. Draw a diagram of a measuring cylinder being used to determine the volume of water. Show clearly the water level and draw with a ruler a straight line showing the line of a site required for accurate measurement. So we have to draw a measuring cylinder here, this part. So a measuring cylinder for a water, we always read the lower meniscus or the bottom of the meniscus. And we will avoid a line of sight error by looking perpendicular. And the markings should be, you don't have to write number, just the markers to show the values. So this was the figure.